Okay, people, let's go over the warm-up. So in exercise 3 through 6, write the expression in terms of sine or cosine. So we've got sine of 22 degrees. How would we write that in terms of cosine? Sebastian, go for it. Cosine of 90 minus 22. Which, when we take 90 minus 22, what do we get, Vinny?
77.
Close.
78.
It's not 78.
No, it's not. 68.
68. Christian, cosine of 56. Which is? 34. And Aubrey, the cosine of 15 degrees is equal to? Yep, sine of 90 minus 15, which is? 75 degrees. Booyah. Okay, so for each of these, just double check. 15 plus 75 should give you 90. Does that give you 90, Stephanie? Does 34 plus 56 give you 90, Anthony? Booyah. And does 68 plus 22 give you 90, Emma? Yes. Absolutely. Okay. So remember, that's because any right triangle, those two acute angles will add up to 90 degrees. So their sine and their cosine will be equivalent. Got it, peeps? All right, let's move on. So before we get started with today's lesson, it's just solving different types of right triangles, okay? So before, do you remember when we talked about the tangent inverse, the sine inverse, and the cosine inverse? And I said you guys don't need to know that right away, okay? This is where you need to know it, okay? So the inverse tangent is used when you have the tangent of an angle equals something, x, let's say. You can say that the inverse tangent of x is equal to a. In other words, you take a, you remove the tangent, and you move it to the other side as the tangent inverse of x, okay? Same thing here. The sine of a equals y. You take away the sine, and you write a equals the sine inverse of y. Same thing with cosine. The cosine of a equals z, then the inverse cosine of z will be equal to the measure of angle a. This is super helpful when we are not given the measure of an angle, okay? Let's say we're given a right triangle and all we know are the sides. We can still figure out the angles of that right triangle using the inverse sine, cosine, or tangent, okay? Let's see an example. So on the next slide, go ahead and cross out everything that's there. And I want you to copy down this problem down below. It says find the measure of angle A. Now, in this problem, listen carefully. It gives us every single side of the triangle, so it doesn't matter if we use sine, cosine, or tangent, okay? Now, for other examples, it will matter which trig function we use, because it will only give us like two parts, and we'll have to use those two parts that it gives us. In this case, since we can use any one, Vinny, pick one, sine, cosine, or tangent?
Tangent.
Let's use tangent, okay? So tangent, who remembers the letters for tangent? It's T, O, and A. So let's look at angle A. What does O stand for? Opposite. What's opposite A? 13. So put an O next to 13. What does A stand for? Adjacent. What is adjacent to angle A? 13 square root 3. So put an A next to that one. Okay? So the tangent of A is equal to what? Excellent. 13 over 13 square root 3, right? Do you guys agree? Because O is our numerator, A is our denominator. So once we have this, now in the past, right, I told you, okay, multiply by the denominator, right? But that's when the variable was on this side. Where's our variable now? In the tangent, right? This is where we write it as A equals the tangent inverse. See how we move the tangent to the other side? We have to use the inverse of 13 over 13 root 3. Tangent inverse, okay? We're going to do sine and cosine. We're going to see that we're going to get the exact same answer. So switch back over to your calculators. Let me clear this. We're going to do the tangent inverse, that's the tangent -1, of 13 divided by 13 times the square root of 3.
Where do you put the inverse in the calculator?
So let me see yours.
Well,
Can you bring it up here? So some of you might not have a inverse function. Okay, so you see the pink one?
yeah.
Or I'm sorry, the yellow one? How it says tangent to the -1?
Yeah.
That's the one you want to use. Do you know how to use those? Oh, you
No
click
idea.
shift and then you click it.
Oh.
So you see how the shift is yellow?
Yeah.
That's going to give you all the yellow values.
Got it. Thank
Okay? All right, so we have 13 over 13 root 3, and that's 30. So when you plug it into your calculator, you should get 30. Boom. Now, let's say we were like, you know what? We didn't feel like using tangent. Let's use a sine. Okay, so take a look at angle A. We're going to find the sine of angle A. What are the letters associated with sine? S, O, and H. So we found what's opposite A, which is 13. What does H stand for? What's that? 26, or the hypotenuse, right? H stands for the hypotenuse, which is our 26. So the sine of A is going to be 13, which is our opposite, over a hypotenuse, which is 26, right? You guys with me? Okay. How do I find A? I just say A equals the sine inverse of 13 over 26. Let's go back to our calculators. I want you to plug in the sine inverse of 13 divided by 26. Close your parentheses and press enter. What do we get for A? If you got 30, you did it right, okay? It's the same answer no matter how we get there. So we use tangent, we got 30. We use sine, we got 30. Should we try cosine? Let's do it. Okay, so cosine. The cosine of A, remember, cosine is what letters? C? So, C, A, and H. So, we already labeled each of our sides. What's A? So, let's put that in the numerator, 13 root 3. And what's H? 26. So here we're going to get A equals the cosine inverse of 13 root 3 over 26. You with me, Christian? Sorry, guys. Forgot to switch it back. Here you go. Now I want you to plug into your calculators the cosine inverse of 13 times the square root of 3 divided, and you should get 30 for the last one as well. Okay. Number 9 from the homework took me a long time. Okay, so on this slide, again, cross out the question that was on the slide. We're going to copy down a new question. We're going to be given a triangle, and this triangle now only has 2 angles that are given. And it's asking us to find the measure of angle D. So let's go ahead and identify where angle D is. Angle D is right here. So this is our reference angle. So now we have to take the sides that were given and give them appropriate names. For example, the 5. The 5 is not opposite, it's not the hypotenuse, so it has to be the adjacent side. And if you look at it, it is next to our angle, it's next to angle D, and it's also a leg, okay? So that's why it's given the adjacent. Now, the 13 is opposite the 90 degrees, therefore it's our hypotenuse, okay? It's the longest side. So we're given the adjacent side and the hypotenuse. So now, if we're thinking about the trig ratios, which one should we use? So, ka, toa. And if we think about these three, cosine, or ka, is the only one that deals with adjacent and hypotenuse. So if we're looking at which one we should use, we should take the cosine of our angle, which is angle D, right here, and it's going to be equal to adjacent over hypotenuse, okay? Which in our case is 5 over 13. So we have the cosine of D equals 5 over 13. Now all we have to do is take the inverse cosine of both sides. So D equals the cosine inverse of 5 over 13. Remember, you're going to use the inverse cosine whenever you're solving for an angle, okay? So we took the inverse cosine of 5 over 13. Let's see what we get. And when I plug that into a calculator, I get approximately 67.3801335 degrees. And let's say it asks us to round to the nearest degree. That would be approximately 67 degrees. Okay? All right, next. So we are able to solve for any right triangle, and at a minimum, we could be given 2 side lengths, which we just saw, or we could be given 1 side length and the measure of 1 acute angle. That is all we need to solve a right triangle. And by solve, I mean we can find out all of the sides and all of the angles inside that triangle. An example, we need to solve the right triangle on the right and round decimal answers to the nearest tenth. So first things first, let's identify what we're given. And right now we're given this angle is 42, this side is 70, and we're given that it's a right triangle with our right angle being at angle C. Now, right off the bat, a lot of people would identify that, okay, we know 2 of the angles inside the triangle, we can figure out the third, okay? And this third angle, angle B, is just going to be 90 degrees minus 42, because we have 42 here. So added with angle B, angle A and angle B are complementary. They must add up to 90 degrees, okay? Or you can think about it as all 3 of the angles in the triangle must add up to 180. But we already have 90 being used by angle C. So we only have 90 left to deal with. So when we take 90 minus 42, we end up with 48 degrees. Okay, so we found all 3 of our angles. Now, our job is to figure out, okay, how am I going to find out CB and AB? If we have any 2 sides of a right triangle, then we can use the Pythagorean Theorem, which says that a squared plus b squared is equal to c squared. So you square both the legs, you add them together, and you can get the hypotenuse. Now, in this case, we only know one of the sides, so we can't go straight to the Pythagorean Theorem. We have to use sine, cosine, or tangent. In this case, let's just say we wanted to use the 2 items that were given to us, so the 42 and the 70. 42 degrees and the 70 feet. So how we would write this is the 70 is the adjacent leg to the 42. So we can use either tangent, which is toa, or we can use cosine, which is ka, because they both deal with that adjacent leg. The one we couldn't use is sine, or soa, because we're not given the opposite leg, which is down here, and we're not given the hypotenuse, which is right here. So we run into 2 issues there, okay? So let's use, just because we used cosine on the last example, let's use tangent here. So let's say we take the tangent of 42 degrees, that is going to be equal to the opposite over the adjacent. See TOA, T-O-A. So once we've set it up correctly, the opposite we don't know, so let's just plug in a variable, x. That means that we've now created x down here as our opposite side. And the adjacent side is now just going to be 70. So we have the tangent of 42 degrees equals x over 70. Now, all we have to do is solve for x. And in order to do that, as I said before, multiply by the denominator. So we just clean everything up. So we're going to multiply this 70, multiply by 70 to both sides. Therefore, the 70s will cancel, and we're going to get x by itself. So we have x equals 70 times the tangent of 42 degrees. Let me use my calculator and plug that in. And when you plug it into your calculator, you should get something like 63.028, which technically just rounds to 63.0, and then just put a degrees. I'm sorry, it's not degrees. It's a length. So we're going to put 63 feet. Okay, so x equals 63 feet. So down here, we're just going to put that 63.0. Okay, so now we've got some options here. We can either use cosine and figure out that hypotenuse, or we could use the 63 and the 70, do a squared plus b squared equals c squared, and then solve for that last side. In this case, since we're dealing with trig ratios in this lesson, I'm going to go ahead and use cosine to figure it out. So let's take the cosine of 42 degrees, and that is going to be equal, it's ca, so we're going to have a over h. In other words, we're going to use our 70 again, but over our hypotenuse, which, let's substitute a variable for hypotenuse. Let's use y. So over here we have y. Once we set it up correctly, let's write it a little bit cleaner. Cosine of 42 degrees equals 70 over y. Let's take out that a over h portion. Now, as I said before, you want to, when you have the variable in the fraction, multiply by whatever the denominator is. So let's multiply by y to both sides. These y's will cancel on the right, and we have y times the cosine of 42 degrees equals 70. From here, you just want to divide by the cosine of 42, because our goal is to get the y by itself. So divide by the cosine of 42 degrees, and divide by the cosine of 42 degrees to both sides. Once we've done that, we have a completed problem where you just have y equals, and then in your calculator, you're going to plug 70 and divide it by the cosine of 42. So 70 divided by cosine 42, and you should get 94.194. 94.194, and since we're rounding to the 10th, it's going to be 94.2. And that is also feet. So we found that angle B, just by using the angle that was already given, was 42 degrees, and now we finally found that the final side, the hypotenuse, is 94.2. So what we would say is that we have completely solved this right triangle. So, okay, example 4, we are going to take a look at. Suppose your school building is a raked stage. The stage will be 30 feet long from front to back with a total rise of 2 feet. A rake, angle of elevation of 5 degrees or less, is generally preferred for the safety and comfort of the actors. Is the raked stage you are building within the range suggested? So what we're looking for is this angle right here, this x, and it needs to be less than or equal to 5 degrees. And we've got a hypotenuse of 30, let's label that h, and we've got a leg, which is opposite our angle, so an O, of 2. So we have to think about, are we going to use SO, CA, or TOA? Well, SOH, CAH, and TOA. And our angle is here, which we don't know, but we do know the hypotenuse and we know the opposite side. which one deals with opposite and hypotenuse? That would be sine. So all we have to do is set it up as the sine of our angle, x, equals the opposite over the hypotenuse, or 2 over 30. So we just take the inverse sine, so the sine inverse of 2 over 30 is x. Okay? Remember, when you're solving for that angle, you are going to use an inverse function. And all I did was, since I knew that the sine of x is 2 over 30, the inverse sine of 2 over 30 will give me that angle x. Okay? So once I found this, I can just plug it into my calculator, and I'm going to plug in sine inverse of 2 divided by 30, or 1 divided by 15, however you want to set it up, and I should get that it is 3.82255 degrees. Or, it doesn't matter, we don't have to round here. We would just say, yes, it is within the preferred elevation, angle of elevation, because it is less than 5 degrees. So we would write, yes, it is less than 5 degrees. And our last example. So this is an example where we're given two sides and we are asked to solve the entire triangle again. So we are asked to find A, B, let's say that C was already given, and this hypotenuse. So we know one of the angles, which is C. We know two of the sides, but we don't know the third, and we don't know two of the angles. Let's just substitute a variable. We'll label this side X. So hypotenuse is X, A and B are not given, and then 20 and 21. Now, some people like to start by finding that third side right off the bat. They're like, we can use the Pythagorean Theorem. All the power to you, okay? If you are going to go that route, you would just do 20, you would square it, you would add it with the other leg, which is 21 squared, and that should be equal to your hypotenuse, which is X squared. A squared plus B squared, both of the legs, squared individually, added together should be equal to the hypotenuse squared. Once we have this, this is 400 equals 21 squared is 441, whoops, plus 441 equals X squared. This is then 841, and then we want to take the square root of that. And we get 29. So 841 equals X squared. You take the square root of both sides, you're going to get 29 equals X. So our hypotenuse right here is 29. Okay, now we have to figure out A and B. But those are easy. We just need to set up a trig function, okay? So let's look at angle A. If we're looking at angle A, 21 becomes our opposite side because it lies opposite our angle. 20 becomes the adjacent leg, and 29 will always be our hypotenuse no matter which angle we're using. So we can use any of the three trig functions for, I don't know, for the sake of this problem. Let's use tangent because 21 and 20 were already given. So let's say we didn't want to use the side that we had to find ourselves. So the tangent of A is equal to 21 over 20. Remember, tangent is TOA, so we're taking the tangent and we're using the opposite over the adjacent. Opposite was 21, adjacent is 20. So we put 21 over 20. Once we have this all set up, I recognize, okay, the only thing I'm missing is my angle, so I'm going to say A equals the tangent inverse of 21 over 20, okay? Remember, when do we use the inverses? It's when we're solving for our angle. So let's take the tangent inverse of 21 divided by 20. And I'm just plugging that into my calculator, and I'm going to get the result 46.39 397, which I'm going to go ahead and round to 46.4 degrees. So we found that angle A is 46.4 approximately degrees. And angle B, you can either use another trig function, or you can just be like, well, I kind of already know what two of the angles inside this triangle is. It's really easy to figure out the third. You just take those other two, subtract them from 180, or if you're really getting this, then you just take 90 minus the 46.4, and you should get 43.6 degrees, okay? Feel free to do it any method that you would like. Just make sure that you're ending up with that as your correct answer. All right, guys, this is the last part for lesson 9.6. Hopefully this is sort of all wrapping together because your test is coming up.